Major support for Do the Math has been provided by CHEVRON, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Bakersfield West Rotary STROOPE Family Foundation, Panama-BUENA VISTA Union School District, Bakersfield City School District, Kern High School District, and AC Electric Company, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we're at Independence Elementary, home of the Patriots, and we're here to All right, today we're at Independence Elementary. We've got some 6th grade students, and we're going to start off nice and easy. You guys all right with that? Mm-hmm. All right. So first of all, what we're going to do is we're just going to talk about math. So the vocabulary that goes along with mathematics. So can you guys think of any vocabulary that is specific for mathematics as opposed to anything else? So think about this for a second. If I said, please bring me the measuring spoons, the measuring cups, I need some flour, and the rolling pin, and set the oven to 350 degrees, who might be talking like that? What occupation or what person might be saying that?
A chef.
A chef, right? A baker, right? Somebody doing some cooking, right?
Yeah.
There's vocabulary that goes with that topic, okay? So what are some math vocabulary words you guys might think of?
Can we go into any kind of vocabulary in general?
For mathematics.
Okay, well, in that case, product,
Product, okay.
quotient.
So let's start with product. Is this a product?
No.
Yeah.
Yes.
It is,
No.
but not in mathematics, is it? Okay, so in mathematics, what does product mean? Do you guys know?
This is the answer to the multiplication.
Right, when you multiply two numbers, the answer that you get is the product. Okay, so product is one of those words that has a couple of meanings, but it has a specific meaning for mathematics. Can you guys think of any other words?
Factor.
A factor, right? There are a lot of factors that go into a decision. But what does factor mean as far as mathematics?
It's a number.
Okay, it's a number. What kind of number is a factor?
A factor is a number that, when paired with another number and multiplied, it equals another number. It's a factor of that number.
There you go. So what would be a factor of 14?
7.
7, right? So factor is another great one, right? Any other words you can think of?
Dividend.
Dividend, right? So if you have stocks, you get paid a dividend, right? Sometimes companies will pay you a dividend for investing in them. What does dividend mean as far as mathematics goes?
Well, like in a division problem, it's the number that's being divided.
So we've got division in there, right? Dividend. Any other words you can think of?
Constant.
What's a constant?
A constant is a algebraic problem to where if a number had a variable with it, so like a letter or such, then this number happens to be without a variable, so it's called a constant.
Perfect. And what would it be in other terms? You guys know, like, when would you ever use constant?
Something that's always happening.
It's always happening. It's constant,
Yeah.
right? So those are some vocabulary words with mathematics, right? And they have other meanings also. So some of the problems that you guys are going to do today, you have to know what the vocabulary means in order to solve the problems, okay? This is a digit, right? What else could it mean as far as mathematics goes? You guys know what a digit is?
Yes.
What is it? It's a number, right? It's an easy one, okay? So some of the problems you're going to see are going to have below, bottom, next to. You're going to have factor, simplify, reduce. What's the difference between simplifying and reducing? Do you guys know what the difference is with those? If you want to simplify something or if you want to reduce it?
When you simplify, you don't like take away from it as like when you're reducing.
Perfect, right? If you simplify something, you're not taking anything away from it. But if you reduce it, you're taking something away. All right? If I went from 2 to 1, am I simplifying or reducing?
Reduce.
Reducing, because I'm taking something away. If I have 2/4 and I rewrite it as 1/2,
Simplifying.
I'm simplifying. See, because sometimes they'll go, take 2/4 and reduce it. Well, if you reduce it, it's going to be less than 1/2. But if you say 1/2, all you did was simplify it. Does that make sense to you guys?
Yep.
So the vocabulary is something that we need to get down first, and I think we've got a good grasp on that. You guys think so?
Yeah.
All right, good. So we'll continue next with the 6th grade students from Independence Elementary. Today we're once again at Independence Elementary, home of the Patriots. We've got some 6th grade students. We worked on some vocabulary last time. Time now to start doing some problems. Are you ready?
Yep.
All right. So some of you will work individually and some of you will work in pairs. What you'll do is, I'll give that down to you. You're going to look at all of the clues on the cards and then figure out how to put these cubes in the correct order based on the vocabulary that is going to be presented to you. All right? So, you guys working in partners, you've got this one all on your own. So the easiest thing to do is to take out all of the clue cards, spread them out, take a look at them all together with your partner, and then start figuring out if you can put the cubes in the exact way that they need to be to satisfy all 6 clues. All right? So who's got number 1? Over here, build it number 1. Read one of your clues.
Each blue block shares one edge with each of the red blocks.
Okay, so an edge. All right, so let's take a look at the blocks. If I put them like that, are they sharing a side or an edge?
Side.
They're sharing a side, aren't they? Okay. Now, if I go like that, what are they sharing?
An edge.
An edge. Okay. Do you guys see the difference?
Yes.
Okay. What about number 3? What have you got? Read one of your clues.
A blue block shares a face with a yellow block.
Okay. So a face. You guys know what a face is? It's this. What else is it as far as mathematics goes, right? See how we need to have the vocabulary, right? So you guys know if you have a cube, right? There are 6 faces.
Yeah.
Okay. What's one of your clues?
The red block is above the green block.
Okay. So if we had red and green, right? The red block is above the green block. So that would satisfy that. Okay. Do you guys kind of get the idea?
Yep.
All right, so with your partner or on your own, look at all 6 clues, build what you need to based on the vocabulary, and we'll see if you guys can solve these problems. All right, go.
So it says there are 2 yellows, 2 blues. The red block is above the green block.
2 red blocks.
Okay, so one of the yellows is above the green block, the other's below it. So that means this one would be on the top.
Yeah, the green block. The other is below it.
No 2 blocks of the same color touch each other.
Now you're gonna have to move.
What about
And then it says down here where the other is below it.
on
That
top?
doesn't mean
Possible.
that.
You guys think you've got it? All right, you keep working on that one. Let's read your clues. So you read these 3 and let's see how it satisfies it.
So the red block is above the green block.
Okay,
It's above it. There are 6 blocks in all, and a tower 6 blocks high.
okay,
And the yellow block is on the top.
very good.
And it says there are 2 yellows, 2 blues, 2 yellows, 2 blues, 1 green, and 1 red in the set of blocks.
All right, what else have we got?
No 2 blocks of the same color touch each other. One
Perfect.
of the yellows is above the green block, the other is below it. And each of the blue blocks shares a face with the green block.
Excellent. All right, let's head down to the last one. Let's hear the clues you've got. We'll see if we can help you out with that last one.
Yeah, this one's a bit weird. A blue block touches a red block and a green block only on edges. The part I don't get, if this touches, does this count as an edge?
How else would you put it?
I don't know. Anyway, so it says that there are 3 blocks on the bottom level, meaning that one of these has to go up. I don't know which one though.
Okay.
A blue block shares a face with a yellow block, so that's why I think this one goes up here, but I'm not too sure about that.
Well, if you think so, go ahead and put that one up on top.
This is what I think, but it doesn't make any sense.
Well, keep reading your clues.
Okay. There's a red block directly below a yellow block.
Okay.
A yellow block touches an orange block along a edge.
Good, so you just have it on the edge like you did.
Oh,
There you
this
go.
counts
Mhm.
as an edge? Oh, okay, that makes more sense. And then there's a red block directly on top of a yellow block. So
You
there,
forgot that.
and then there are 6 blocks in all. An orange block shares a face with a green block and 2 others. Oh.
There it is, perfect. Nicely done. So making sure you've got the vocabulary and the placement of the blocks all set up like that, the 6th grade students doing incredible work at Independence Elementary. Once again, we're at Independence Elementary working with some 6th grade students, and today, this time, you guys are going to work on a little race with each other. Are you ready?
Yep.
Okay. So you saw how last time with the cubes, you had some clue cards, and you read those clue cards, and you tried to put the blocks in a certain order.
Yep.
Same thing you're going to do now with pattern blocks. All right, so we're not going to use cubes anymore. We're going to have pattern blocks. So let's first take a look at the blocks we have. So, what are any of those shapes? Anybody know?
It's a trapezoid.
Trapezoid,
Rhombus.
rhombus.
Parallelogram.
You can call that a parallelogram also, right? What else have we
Triangle.
got? Triangle, right? Pretty basic. 3 different shapes on there. Okay? What you're going to do is you're going to, you know what? Who's going to work as a partner? You 2 are partners?
Sure.
Very good. There's your set, and there's your set. All right? So, once again, you need to look at all 6 of the cards. So here's what I want you to do so that we make this even. Take out all of the pieces and take out all of the cards. But put the cards turned over so that they're face down. You can spread them out. And you can see on the back of the cards, you have numbers or letters written on them. That way we don't get them all mixed up. All right? You can take apart your cards and spread them out. Who thinks they're going to win this? Oh, confidence. All right, good. Here we go. You know what you need to do? You need to look at the clue cards, see if you can put together this in the fastest time. Are you ready?
Yep.
On your mark. Get set. You can turn over all the cards at one time, too. You don't have to only turn them over one at a time. Go.
Each blue piece touches another blue piece. So, use pattern blocks to help you. Each blue piece touches another blue piece. These have to touch. Guys, I'm pretty sure we're making a triangle. These are small triangles. Maybe eight.
Find out.
This is at the top. Yeah, that's probably right.
Done.
And the red and green
Done.
pieces
Can't touch
that's
Twice as many blue pieces as green ones.
Oh, yeah.
Each blue piece
Or
touches
that.
another blue piece. Let's try and make this rounded.
This triangle doesn't touch anything.
Like this?
This is the very top.
Or maybe red and green pieces form 2 identical.
Keep working on it. Now, you have finished it first.
Yeah.
So, as these guys are still working on it, read off each clue and let's make sure that everything is satisfied correctly.
The red and green pieces form 2 identical small triangles that are part of Terry's triangle.
Yes.
Okay,
Each blue piece touches another blue piece.
good.
There's a red piece right in the middle and on the bottom of Terry's triangle. There are a total of 8 red, green, and blue pieces in Terry's triangle.
Okay.
The green piece that's right at the top of Terry's triangle doesn't touch another green piece. And there are twice as many blue pieces as green ones and half as many reds as blues.
There's a lot of vocabulary in there, right? But you guys were able to figure out. All of you have done that successfully. Nicely done, accomplishing Terry's triangle with the 6th grade students at Independence Elementary. All right, today we're at Independence Elementary working with some 6th grade students. You guys have done a little bit with vocabulary, putting cubes together, using pattern blocks, looking at the directions, trying to figure out the shape that you need to make. You've worked in pairs and individuals. Now what you're going to do is you're going to work all together to do one task. All right, so here we have a lot of different pieces. Okay, so what we'll do is we'll turn them over so that we can see the letters. All right. So what we're going to do is the A's you're going to have. All right. The B's we're going to put with you two right there. All right. The C's are going to be yours, and the D's are yours, okay? Now what you need to do is, using all of those pieces, you're going to make 4 squares, okay? Now you're not going to make squares only with your letters. You have to put your A with a B and a C or a B and a D somehow, okay? How many pieces are there altogether?
12.
There are 12 pieces. And if we need to make 4 squares, how many pieces will be in every square?
3.
3. There will be 3 pieces. All right? So you can't use an A, B, C, and a D to make a square, because that's 4 pieces. You can only use 3 pieces to make a square. So it might be an A, B, C, it might be an A, B, D. You don't know what the combination is yet. All right? But this is going to take a lot of work, cooperation, for you guys to make 4 squares. Do you guys understand how this goes?
Yep.
All right. The squares will all be the same size at the end. So it's not like there's going to be like C already as a square, but that's not going to count as one of them. Okay. Everything's going to be larger than that. Okay. Go. Let's see how you're going to do this.
Hold on, I think that the C square goes over there, and then we use our triangle over here. Over here.
Yeah.
Okay, there's a square right there. That was pretty quick.
Can I have that rectangle?
Oh, this. Sure. Yeah, that works.
And then,
C goes like right.
and then,
No.
You got 2 done pretty quick there.
Oh, I got it.
and then
Dang.
Wait,
that goes.
No, wait.
There you go. Keep moving them around. Remember, no 2 letters will be the
We
same.
need a smaller one.
Oh yeah, and then this one goes over here.
There.
All right, so let's take a look. You guys did that pretty well working together. So, as you were doing this, what was going through your mind? Like, what were you thinking of? How did you accomplish it so fast? What were some of the strategies that you used?
Well, we had to find shapes that would fit together and would make a square shape.
And using basic things like 2 triangles make a square. So if you put the 2 triangles together, there will be a square.
Okay.
Or a rectangle.
Just depends on the size.
Yeah.
So there were a lot of different things that you guys used, and just using your basic knowledge of other shapes, you figured out how you could put these together and get those 4 squares. Well, you know what? Nicely done. You guys accomplished that in record time, as a matter of fact. I don't think any other group has ever done it that fast. So nicely done, the 6th grade students at Independence Elementary.
You got it.